Okay, and this video is about the law of sines. We are now going to be working with non-right triangles, and we are still going to be solving the triangle. So we are going to again be given three pieces of information, and you have to find the remaining three. Okay. Bellword purposes, let's do a solving right triangle so we can get back into the groove of solving triangles. So we have angle A is 50 degrees and side A is 25. So again, let's label the triangle. So we have angle A up top, 50 degrees. Side A is directly across from that, so side A is 25. And angle C is that right angle. Again, remember, with any right triangle, then the right angle is C. Okay, so we are going to find three pieces of information. We need side C, we need angle B, and we need side B. Okay, and again, let's go ahead and set up which ones are opposite, adjacent, hypotenuse, because we're going to need those. So if I'm using angle A, I'm going to go straight down here. This is my opposite side. This would be my adjacent side. And this would be my hypotenuse. Okay. First and foremost, since angle B is the only angle that we are missing, let's go ahead and solve for angle B. So angle B is going to be equal to 180. Again, how many degrees is inside of a triangle? 180, because of the triangle sum theorem. Minus the 90 degrees for angle C, minus angle A. Okay, so we have angle B is equal to 90, 180 minus 90, minus the 50 degrees for angle A. So angle B is equal to 40 degrees. For the remaining two pieces that are missing, the side lengths, we're going to set up the ratios. So we have to set up sine of 50 degrees is equal to the opposite, which is the 25, over the hypotenuse, which we don't know. I'm going to set up cosine over here. So cosine of 50 is equal to the adjacent over the hypotenuse. Notice with cosine, we don't have two pieces of information. And again, in order to solve for something, you have to only be missing one piece. So I cannot use cosine here. So I'll go ahead and cross that off. Tangent of 50 is equal to the opposite over the adjacent. Okay, and again, we have to work through the process of solving these. So both of these pieces that are missing are in the denominator. So we're going to again multiply by the denominator and then divide by that function to get rid of it. So here, we're going to multiply both sides by C, because again, that's in the denominator. Gives me C times sine of 50 is equal to 25. I would divide both sides by sine of 50. Which cancels these two. And that would give me then the value of C to be approximately 32.64. Again, as far as plugging in these into calculators, you're going to have to identify what type of calculator you have, as well as how to plug it in. Every calculator can do these as long as it's a scientific calculator. The problem is trying to figure out which buttons to push and in what order to push them. Okay, solving for B, we're going to multiply both sides here by B. That gives me B times tangent of 50 is equal to that 25. Again, I'm going to divide both sides then by the function here, so tangent of 50. Which is going to give me the value for B to be approximately 20.98. Okay, moving on. Okay, again, just a review of solving triangles here. You're going to be given in a right triangle 2 pieces of information, because again, that third piece is the fact that it is a right triangle. You're going to be either given 2 sides, or you're going to be given 1 side and 1 angle. For any other triangle, you're going to be given 3 pieces of information. You can be given 2 sides and 1 angle, or 1 side and 2 angles. Okay, and what we need to do is, just like with right triangles, we're going to solve for the remaining 3 pieces that we do not have. Okay, law of sines. I'm presenting it here in 2 different fashions. You'll notice that one on the bottom is just the reciprocal of the one on the top. It doesn't matter which way you do it. I will actually identify all of them as the top portion there. Sine of angle A divided by side A is equal to sine of angle B divided by side B, which is then equal to sine of angle C divided by side C. Okay, but you can use either function. Okay, a word of caution here. There are times when these triangles will have only one solution, or there's times when it will have no solution. So if you plug into a calculator and you get the word error, then it could be okay, all right, depending on the problem. You may have plugged it in wrong, or you may have plugged it in correctly, and it just means that it's not possible. Okay, so there could be no solution, there could be one solution, or there could be 2 solutions. It just kind of depends on how we move the legs that we are given. Okay. Focus here, we're going to focus on the situations where we have at least one. All right, I will give one where there is an error or no solution, just for identifying that purpose. But obviously we don't have a lot of time to work with these, so I'm going to focus more on having at least one solution. Okay, so the last 5 pages of notes here are actually just 5 examples. So we'll work through each one of them in order and see how that happens. Okay. So here, you'll notice that we're given 2 angles and a side. My suggestion is to, again, go ahead and label these triangles. It doesn't matter where you place things. Again, it's just for a visual thing. Some people are going to get freaked out a little bit because an angle says it's, let's say, 95 degrees, and maybe somebody wants to put it in, the bottom left-hand corner here. Okay, I would go with the 95 degrees being here. So this is angle C, 95 degrees. We can call this angle B. This is 45 degrees. And then side B is still opposite of angle B. Okay, so that part doesn't change with a non-right triangle, right? Let's again identify then which pieces we need to find. We need to find the angle A. I don't have side A, and I don't have side C. Okay. Please note, you cannot use Pythagorean theorem for these. These are not right triangles. You can only use Pythagorean theorem in the event of having a right triangle. Okay, so set up the law of sines. Actually, first, let's go ahead and solve for angle A. Angle A is the only one we're missing. So angle A is equal to 180 degrees minus the 2 angles that we have. So angle B and minus angle C. So angle A is equal to 180 minus that 45 minus the 95. So that means the angle A is equal to 40 degrees. Okay, so then we set up the law of sines. So sine of angle A, which we found to be 40 degrees, so 40, over side A, we don't know side A yet, is equal to sine of angle B, which was given as 45, over side B, which was 32, which is equal to sine of angle C, which is given as 95 degrees, over side C, which again we don't know. Okay, when you're using law of sines, you'll notice that there is one of these fractions that is completely used out. My suggestion is to utilize that fraction, okay, in both pieces here. So what I'm going to do is I'm going to look at one side, okay, I'm going to use these two together, and I'm going to solve for the one piece that's missing, okay? This is working with proportions, and you're going to use something that you used quite a while ago, and we're going to cross multiply, okay? Cross multiplication means that we're going to take the numerator of one times the denominator of the other, and vice versa, okay? So here I would have 32 times sine of 40 is equal to A times sine of 45. Okay? We're trying to solve for side A, so here I can just divide both sides by this sine of 45. Okay, you're going to take time to plug that into a calculator. Again, be very cautious on how you plug this into the calculator. You're going to have to reach out and find out how to use your particular calculator if you can't figure it out. Okay, but when you run this through, you should end up with A being about 29.09. Okay, then we're going to go back to that equation up top there, and again I'm going to utilize that one that's already completely filled out. I could plug in the A value and use it, but again I would say use the one that we have for sure all the information for. So I'm going to do a similar situation here where I'm going to take now these two and use them in the same fashion. Okay, so again I'm going to cross multiply, so here I have C times sine of 45 is equal to 32 times sine of 95. Okay. I'm going to divide both sides by sine of 45. Which is going to give us a value for C of 45.08. Approximately. So it's approximately 45.08. Okay. Moving on to number 2 here. Number 2. In this example, you are given that angle A is 120 degrees. Side A is 50. And side B is 25. Okay, so again, I'm going to label the triangle angle A. I'm going to put up top here because, again, this angle looks visually larger. Okay, I have side A, which is 50. And let's call this side B. Okay, you get to pick between these two. It doesn't matter which one you use. You put A here. Okay, so again, identifying the things that I'm missing here. Since this is side B, then angle B has to be here. Side C, I don't know. And angle C, I don't know. Okay, so here, on the last problem, we were able to use the two angles that we were given to find the third angle that was there. Okay, but here we don't have that situation. So we go ahead and set up the law of sines right away. Okay, so sine of angle A, which is 120 degrees, divided by side A, which was 50, is equal to sine of angle B over side B, which is equal to sine of angle C over side C. Okay, with the problem in this nature, you'll notice that there's one of the fractions that we can't use because it's missing two pieces of information. Okay, so for this one, we can't use the sine C over C yet because it's missing two things. Okay, however, the first part there, sine B over 25, we can use with the sine of 120 over 50 to solve for angle B. Okay, remember here with something like this where we're solving for an angle, as in with what we did with the solving right triangles, we're going to have to use the inverse function. So anytime you are solving for an angle, you have to use the inverse function. Okay? But we're going to still cross multiply. Use these two. Cross multiply. So I have 50 times sine of B is equal to 25 times sine of 120. Okay. I can divide both sides by that 50. Okay. In order to get rid of, again, the sine off that angle B, I have to use the inverse function. So I'm going to rewrite this and space it out a little bit more. So I have sine inverse of sine of B is equal to the inverse sine of this whole thing. So 25 sine of 120 divided by 50. Okay, and again, these are going to cancel. So it leaves me just the angle B. Okay, and again, when you're plugging things in like that right-hand side, it can get kind of difficult, again, depending on what type of calculator you have. Okay, so make sure you're able to do this correctly. You should end up with angle B being approximately 25.66 degrees. Okay, from here, you're going to go ahead and find now, since we have two angles, you're going to find angle C. Okay, so let's do that up there. Let's do it down here in the bottom left-hand corner. So angle C is equal to 180 minus angle A minus angle B. Okay. Here, note that I'm going to put angle C is now approximately 180 minus the 120 minus the 25.66. Okay, and again, I'm using approximately because angle B is not exactly 25.66. It's rounded off. Okay, so this gives my value for angle C to be approximately 34.34 degrees. Okay, so what I'm going to do here then is I'm going to take this information we just found, and I'm going to take this uppercase C out of here, and I'm going to put that in there now. Okay, but I'm still going to use that one that was originally fully filled out. So I'm going to still use the A here with that function over there. Okay, so I'm going to cross multiply. So I have C times sine of 120. Okay, again, the denominator times the numerator. And that should be equal to 50 times sine of 34.34. And then here I'm going to divide both sides by sine of 120. Okay, these cancel out. That gives me C to be approximately 32.57. Again, 32.57. Okay, so 3 pieces of information missing, 3 pieces of information found. Okay, and due to the great bell schedule still maintaining, we'll hear another bell in just a couple more minutes as I'm in the middle of problem 3. Okay, maybe I gotta find problem 3. There we go, problem 3. Okay, problem 3, again, is a situation where I'm given one angle and 2 sides. So I'm going to go ahead and label, again, as I choose. Angle A could be, again, whichever one you want it to be. So let's say angle A is up here. It's 65 degrees. Side A is 20. We'll say side B, again, just for the purposes of staying consistent with the last problem. Side B is up here, 53. So now I'm missing, again, angle B, side C, and angle C. Okay, so similar to the last problem, what you're going to have to do is you're going to have to plug in to the law of sines right away. Okay, so sine of 65, angle A, over side A, is equal to sine of angle B divided by 53, because that's side B. Is going to be equal to sine of angle C over side C. Okay, so in a similar fashion here, we're going to take the first 2 fractions and we're going to solve for angle B. Okay, so we got to cross multiply. We have 20 sine of B is equal to 53 sine of 65. We're going to divide both sides here by 20. Okay, and again, for the purpose of getting rid of sine, then we have to take the inverse sine of both sides. So again, I'm going to space it out here. So inverse sine of the sine of B is equal to the inverse sine of 53 times sine of 65 divided by 20. Okay, inverse sine and sine will cancel out, and that is going to give me angle B. But when you plug this into the calculator, you'll notice that it should give you an error message. So that means that the answer is that there is no triangle possible. Okay, you cannot create a triangle using the information that we have been given. Okay, so this is that one. This is that one case where, again, you could have no solution. So again, if you have an error message, that doesn't mean that you've necessarily messed up. It could mean that I gave you a triangle that did not actually have a solution. Okay, moving on to number 4. Okay, again, I'm going to label then. Angle B is the only one missing here, so I'm going to have angle A up top, 72 degrees. And we can stay consistent here and put C up top here, 35 degrees there. Side C to 65. So I am missing angle B, side B, and side A. Okay. This is a similar situation to number 1, where I have 2 of the angles that have been given to me, so it's pretty easy to find the third angle. So let's go ahead and find angle B right away. So angle B is equal to the 180 minus angle A minus angle C. So that means angle B is equal to 180 minus the 72 minus the 35. So angle B is equal to 73 degrees. Okay. From here then we're going to set up the law of sine. So sine of angle A, which was 72, over side A, which we don't know, is equal to sine of angle B, which we just found to be 73 degrees, over side B, which we don't know, is equal to sine of angle C, which was given as 35 degrees, over side C, which is 65. Okay, here again we're going to pick 2 of these fractions to utilize and cross multiply. So again, I would use the last one here. It does have all of it filled out. Okay, so I'm going to start on this side 10 this time and cross multiply. Okay, so I have B times sine of 35 is equal to 65 times sine of 73. I'm going to divide both sides by sine of 35. And that's going to leave me side B to be approximately 108.37. Okay. Then I'm going to use the other 2. So again, I'm going to use this one that's filled out completely. And I'm going to use it now with this first fraction because I need to find side A. Okay, so again, cross multiply. A times sine of 35 is equal to 65 times now sine of 72. I'm going to divide both sides by this sine of 35. That's going to give me my value of A, which is approximately 107.78. Okay, something to note here. If you pay attention to the angles and how many degrees they are, okay, the largest angle should be across from the largest side. The smallest angle should be across from the smallest side. And the one in the middle should be in the middle on the length of the sides. Okay, so notice here, angle C is only 35 degrees. Okay, so therefore, side C is 65. Okay, and if we look at the angle for angle A, it is 72 degrees. Okay, which is the next one up, right? So it's the second one. Then 107.78 is the second largest side. And then side B, which is angle B, which is 73 degrees, is across from the largest side, which is 108.37. If you run into a case where you find values for things and your largest angle is not across from your largest side, or your smallest angle is not across from the smallest side, then your answer could be incorrect. Okay, so be conscious of that. Number 5. Again, let's label things. I'm going to switch it around here a little bit now because this is 34 degrees. So if I put 34 degrees in here, some of you are going to freak out a little bit because it doesn't look like 34 degrees. That's okay. Notice that all of them that I give you are exactly the same triangle. It's just for a visual representation. Okay, so I'm going to put angle C here this time. It's 118 degrees. I'm going to put angle A then here in place of this C that it was, the 34 degrees. And side A is 15, so here we got it here. Okay, so we are missing angle B, side B, and side C. Okay. Again, we have a situation here where we have two angles that are presented to us. We can find the third angle then. So let's go ahead and do that first. Angle B is equal to 180 minus angle A minus angle C. So that angle B is equal to 180 minus the 34 degrees minus the 118 degrees. So angle B is equal to 28 degrees. From here then we're going to set up the law of sines. So again, sine of angle A, or 34 degrees, over side A, which is 15, is equal to sine of 28 that we just found, over side B, is equal to sine of 118 over side C. Okay, and again, we're going to pick two of them to use. This one, the very first fraction, is completely filled out. So again, we're going to utilize that one both times. So I'm going to use these two first. Again, cross multiplying, that's going to give me B sine of 34 is equal to 15 sine of 28. To get rid of sine of 34, I'm going to have to divide both sides by sine of 34. It's going to cancel these, and that's going to give me that B is approximately 12.59. Okay. Again, likewise, I'm going to utilize this one, and I'm going to go with the last fraction now. Okay, cross multiplying, I'm going to have C times sine of 34 is now equal to 15 times sine of 118. I'm going to again divide both sides here by sine of 34. And that's going to give me a value for C to be approximately 23.68. Okay. In my curriculum, we have 2 days of the law of sines. So you have equal opportunity to get help and assistance if needed. Okay, there are 6 problems per worksheet. And if you have any questions, again, comments or concerns, by all means, please feel free to get a hold of me.